Hi, G12 and G11. Welcome back to the family. Today, in this tutorial, we'll be specifically looking at the applications of trigonometric functions. And I would like to advise you guys again, be with me until the end of this session, since we're going to discuss all the necessary checklist based on the applications of trigonometric functions. If you feel like you do have some further questions, don't hesitate to email messiando95@gmail.com, or you can hit me on WhatsApp via the number, which is just an 071 576 8614. So today we are not going to tackle down the questions, but we'll be just looking at the checklist based on the applications of trigonometric functions. Just a short question, this one. It's just a short topic, sorry. So it doesn't need you to really stress a lot. With this, what you're seeing here, it is all what it is precisely needed from you to master. In order for you to flow in each and every questions that you'd be taking down based on the applications of trigonometric functions. So just allow me to take you through, guys. As you can see, when we talk about this and applications of trigonometric functions, is divided into two rules. The first one, which is just the area rule, sine rule, and the cosine rule. So we're going to apply all these rules on any given triangles, depending actually on the properties that are here under this checklist. So I'm going to explain each of the rules that you are seeing here. So the applications of trigonometrics just consists of three rules, which is just your area rule, sine rule, cosine rule. As you can see on my table here, we have got the formula of each rule. The first one is for the area rule, sine rule, and the cosine rule. You can write the rule here on it, the area rule. This is the sine rule. So the formula of the area rule is just denoted as, depending on the triangle that you'd be using at that particular situation. The area of, as an example, I'll be referring on this triangle that you're seeing here. My triangle is just on A, B, C here, as you can see. And it is also depend on the side that you are actually given. The area rule said half, you multiply half multiplied by the two given side that you'll be given on that particular triangle. So it's going to be 1/2 times A times B. So since you took or you selected the side which is the A, B, then the last side, which is just the C, instead rather of selecting it, you would just select the angle. As you can see here, the angle of this area rule is the included angle between these two sides that you selected. Have a look. You selected the value of A multiplied by the B. So the angle that we are referring on, it is the included angle, is the angle that is between the two sides that I'm actually given or that I'm actually using. So this is the right angle that I have to use on my area rule. I'm not going to discuss much when it's come to the formula, but I want to show you how to determine which rule to use, because this is exactly what it is quite important when it's come to these applications. As an example here, we can assume that the same triangle, which is just an ABC, I am given this side as 2 unit, and this is as 3 unit, and also we given this angle as 30. I want to calculate now the area of this particular triangle. So what I'm going to do, obviously, it's going to be 1 over 2 times the side which is the BC, 2 multiplied by the side which is just the 3. Even if you given this angle rather maybe is just 60 as an example, um, let's just take it if it's an isosceles triangle, this is 30 again. Even if you given this angle here as the just allow me to make it different so at least it can really make sense. Even if you're given the angle here as the angle B here, you don't have to come and say this is the sine of the angle B, because the angle that we have to use here, it must be the included angles. It have to be between the two sides that you actually using. Since you selected the 2 and 3, the angle it must be between those two sides that you selected. So instead of using the sine of 60, we're going to take the sine of 30. So when you punch everything here, you are going to get the area of this. So it is not all about the side of a B, the A and B. It can be any side depending on the question actually. So that's it. That's how we use the formula of the sine rule. Next one. The next one is the sine rule. The sine rule, the formula of the sine rule, it is denoted like this. We have got two ways of representing the area of the sine rule. You can decide to use exactly what you are seeing here, or instead rather of writing sine of A divided by A, this A, small letter A, B, C representing the sides, whereas the capital letter A representing the angles here. You can see here on my triangles that I'm referring on. So obviously, if you're using the sine rule, we can use all these three ratios at the same time. You just have to select 2 so that you can able to cross multiply. We can cross multiply this 3 information at the same time. So you have to select only 2 of this. Mostly when you will understand when I explain in detail how to select or how to determine which rule to use, or what is it that we must put into consideration when we apply this sine rule. So for instance, we can take it as an example that this triangle that is given, same applies here, or just allow me to use another triangle again, A, B, C. I'm given this 2 and 3, same 30, and that angle of 60 there. So when you apply this, mostly you'll be finding the side or an angle depending on the question. As an example, let's take it if we're looking for the side AB here. If we're looking for the side AB, what is just an that corresponding angles, the opposite angles for this side? This side is actually or this angle pointing to this side. So the angle of this side that I'm actually looking for, I'll use the 30. The B, it is pointing the side which is 3, whereas A pointing the side which is just the 2. So the first thing for you to do is to consider the side that you are actually looking for. I am looking for the side which is just the AB, so I have to consider the angle of my AB together with the side AB because I'm looking for AB. So it's going to be just the sine of my 30 degrees divided by the side which is AB. It is also allowed just to write it in terms like this as your AB, which is equals to another given side together with an angle, because we can't solve two unknown at the same time. You make sure that the side that you're selecting, even the opposite angle, it is well known. So obviously we're going to take this one for the 60 instead of taking one for 2, because we're not given the angle of A, but you can also find it here. Also, the best way you just select the one that is actually given to you. So we just the side 60, side A. It's just 3. So we have to make A B to the formula. You're going to just and get to the formula. So the formula of the sine, it can also represent in this way round. Instead of starting with sine angle, you can start with the A on top, divided by the angle sine A underneath. Same applies here. B divided by the sine of B. It is the same stuff. It's going to give you the same solution at the end. Done. Then we come to the last one, which is just your cosine rule. The cosine, we have got our formula, just an A equals to the B squared plus C squared minus 2BC dot cos of A. Yeah, same applies here. You have to make sure that you might be looking for an angle, you might be looking for a side, depending on the question. This is the right formula to use for the cosine rule. For the cosine rule here, you must have these two sides must be given together with the angle of this side that you're actually looking for. But other than that, just allow me to take you direct or in detail so you can understand when do we apply each of the following rule. Number one, how to determine which rule to use when it's come to the area rule. What you have to understand, or what you must be careful of, you make sure that the triangle that you're actually using, first of all, check if you do have or if you do not have the perpendicular height given. Unfortunately, if the perpendicular height it is given on that particular triangle, means that you cannot able to apply this area rule. So when do we use the area rule? We use the area rule only if the triangle it doesn't have the perpendicular height. As an example, then the triangle having the perpendicular height, we're talking about the right angled triangle. It can either like this, but as long as we don't have this perpendicular height here, giving us the angle which is close to the 90 degrees. So if we are facing, or if we are coming across this kind of the triangles, we are not allowed to use the area rule. So we use only the area rule in such a triangle like this without having the perpendicular height on it. Yeah, that is the reason, or that is exactly what you have to put into consideration when you apply the sine rule. So number two, when it's come to the sine rule, when you apply the area rule, yes, here it is. When it's come to the sine rule, number one, no right angle is given. So again, you have to go and identify the triangle. Do I have the right angle given on my triangle? If you find that there is a right angle given on your triangle, it is prohibited for you to use the sine rule. You make sure that again the triangle is look like this. It doesn't have the right angled or it is not a right angled triangle. So in other way round, when you apply the sine rule, the right angle triangle, it is prohibited for you to take it further and use the sine rule. If you see the triangle having the 90 degrees, don't even start and apply the sine rule. Also, don't even start and apply the area rule. So you firstly identify the type of the triangle. Maybe if it's an isosceles triangle, yes, equilateral triangles, but make sure it's not the right angled one. Okay, case number two, you make sure that okay, the two sides and an angle are given, but not just an ordinary angle here. When it's come to the sine rule, be careful here, because this at least for the sine rule and look familiar, the one for and the sine rule here, the side two side and an angle are given, but not the included angle. Here they said there's two sides and the included angle are given. Two sides are given. This is the two sides and angle, but here the angle we're talking about is the included, whereas this is not an included. It's not an included one. So what is the included one? What is the included angle? An included angle, or just me to start with, this is not the included angle. Given triangles such as this A, B, C, 2, 3, again 30, and the 60, like this. Depending on the side that you're using. When we say the angle, included angle, is the angle that is not that you'd be using. If you decide to use these two sides, 2 and 3, this angle 30, it is between 2 and 3. As a result, that this 3, it is an included angle because I'm using this 2 and 3. Is the included angle for the roots. So if I'm applying the rule, I select one angle that is not included, or angle that is not in between the two sides that I'm actually using for the sine rule. That's it. So when we talk about an included angle, here it is. This is an included angle found in between the two sides that you'll be using. So this one only applies on the cosine rule because they say two sides and the included angle are given. Two sides are given and also the included angle. This is included angle, but this one is included angle. That's it. So lastly, under sine rule, the two angles and a side are given. You can also apply the sine rule. When it's come to the sine rule, no right angle is given again. So meaning that in or on each of the following rules, either there's area rule, sine rule, and the cosine rule, you are prohibited to go with the right angled triangle. Prohibited to use that triangle in each this case. When you see the right angled triangle, forget about any of these rules. But I'm sure that you will be having the question, that is not the stop giving us the triangle which is angled one. What might I do if I triangle like that? If you get the triangle such right angle triangle, you only use the trigonometric ratio functions or together with the Pythagoras to find either the angle or the missing side. You don't have to use any of this. This rule applies only if the angle doesn't have the 90 degrees on it. So these are the checklists that you have to familiarize yourself with before you tackle down the question based on the application of trigonometric functions. So just allow me to end here. Then on the next session, I'll be doing the questions with you, since now we hope you have mastered the application of trigonometric functions, the checklists that it is needed first before you answer questions.